equation. It says, if a wave has a frequency of 80 hertz and a velocity of 6,640 meters per second, find its wavelength. So to do that, we're going to need to look in the reference table to see if we can figure out if there's an equation that has frequency, which we know is 80, and velocity, which we know is 6,640 meters per second. And we want wavelength. So this symbol here, maybe you don't know this yet, but this symbol here stands for wavelength. So I'm just going to scroll down. And when you look at the wave section of the reference table, it looks like this. And we are looking for something that has wavelength, velocity or speed, and frequency. So we're going to look at our equations on the left-hand side over here under waves. So right off the bat, it's this equation here, V equals frequency times wavelength. So that is the equation that I'm going to be using. So velocity equals frequency times wavelength. Now, I should point out for this focus, sometimes these words change. So this is asking for frequency, or it gives you frequency and velocity and asking for wavelength, but that might change in future focuses. So you might be given the wavelength and frequency and asked to find the velocity, for instance. So for this one, we would do 640 meters per second equals 80 hertz times the wavelength. And then you would grab your calculator, which I'm grabbing right here, and then so to solve for the wavelength, you would divide by 80 on both sides, and so 6,640 divided by 80 gives me 83, and then what is the units left over? So that's a really good question. So meters per second divided by hertz. Now, it's going to be helpful if you can remember what hertz really equals. Hertz is a fancy way of saying 1 over seconds is what that is. So we can rewrite this to be meters divided by seconds divided by 1 over seconds. Okay, but if we're dividing fractions, what do? We're going to keep the first, change the sign, and then flip it. So seconds and seconds cancels out and we're left with meters. So it's 83 meters, which makes sense because it's a wavelength. It wants a length. So meters is the appropriate unit for that. Okay, moving to the next one, it says find the period of the wave. So this one, we need to somehow use the numbers that have been given to find period. So we learned this last week to find period, but just to show you in the reference table, this is the equation here. Capital T stands for period, and it's 1 over frequency. So if I bring this back up here, T equals 1 over frequency, and it's lucky us, it's given to us. We know that it's going to be 1 over 80 hertz, and then of course you put that into your calculator. 1 over 80 gives you 0.0125, and again the units for period are seconds, and if you wanted to see that done dimensional analysis, it would be 1 over seconds, which would be like 1 divided by 1 over seconds, so it's the same thing. You keep, change, flip, and it becomes the seconds comes into the numerator and it gives you that. So that is how we do the focus for this week.